Hey guys, welcome back to the next episode of the Python Intermediate series. In this video, we're going to be going over the enumerate function. So the enumerate function basically gives you back the index and the value of an iterable. Why this might be useful is for direct lookup of an index and value at the same time, and if you want to manipulate some data without having to loop through the whole list again. With this being said, let's go ahead and declare a list x of values 1, 2, 3, 4, 5. And if we just print x by itself, we'll go ahead and get 1, 2, 3, 4, 5 the list back. And if we want to loop through all the items, we can say for num in x, let's just print the num, and we get 1, 2, 3, 4, 5. Now there might be one of two ways in which we get the indices of this list. The first way is you might declare a global variable here for the counter, and we will print the counter variable and the number associated with it every time, and then we'll increment the counter after each iteration of the loop. And when we do this, we get our indices of 0, 1, 2, 3, 4, since it's a list of length 5, and we get our values 1, 2, 3, 4, 5. Another way we might do this is we get rid of the global variable, and in our loop, we'll go ahead and loop over the indices of the list. So with that, we can just do the range of the len of x. Len of x is 5, so it's going to be from 0 up to 5. And then we can just access the indice of the list x. And we don't need to increment I anymore since we're automatically doing that in our range function after every loop. And we do that, we get the same result. Now doing this, as you can see, we have to look up the value of the indice at every position in x. So we have to actually go back and search through this list, which takes more time than actually just O of n, just going through this one time. So the more better way to do it would have been the way that we did it before, which was using the global variable way, such as this. However, with that, again, this kind of looks kind of yucky, it's kind of hard to read a little bit, so we can simplify this with the enumerate function. So to do this, we can just type enumerate and then pass in our iterable, which is x. And now, what enumerate gives you is it actually gives you back the indice and the value, which you can unpack here. So we can say I and val, and then we'll just print I and val, and our output will be the same. We have our indices on the left and our values on the right. So with that, we can have direct access to the indice and the value at the same time, only looping through the iterable one time, which is great. So let's do an example of this. Let's make a graph. And we'll declare our y's as 100, 200, 300, 400, 500. And we'll say our x's are 1, 2, 3, 4, and 5. And actually, let's go ahead and make them 0th indexed. Just like that. And when we call plt.plot, well, in matplotlib, we can go ahead and just pass in these, and then the x's will be considered as the indice of each one of these will be the same as the x's list here. And I'll go ahead and show them both ways. So let's just save the fig as my graph. And when we run this, we'll get our graph over here, and you can see here on our x-axis, we have 0, 1, 2, 3, 4, up to 4, and the fourth value is at the value of 500. Then we got 300 at 400, 200 at 300, 100 at 200, and 0 at 100. And like I said again, if we just pass x's here instead of the y's, and we run this again, and if we take a look back at our graph, we have the same result. Now here comes the enumerate part of this. So let's say that instead of having 0, 1, 2, 3, 4 as our x's, we want to have it to be the squares of each one. Now, of course, I could come in here and be like, 4, 9, and then 16. And when I run this, our graph will look different with the square values on the x's. However, let's go and do this dynamically. So, let's say our list was 10,000 units long, right? So let's go for I and val, and we want to enumerate over the y's. And let's just say x's.append, and what do we want to append? We want to append the I, right? So if we do this and we run it, And I'm sorry, we need to say in. And when we run this, I'll go ahead and get our graph again of our straight line. Remember 4 representing 500, which is the end of the list. But now we want to make sure our x's are the squares of each time. So to do that, we'll just square each term of the index of I coming in. And now our graph is that logarithmic function again of the squares of the x's, and they're still associated with the same y values. So now we're not having to go and look up y's. We already have them right here. So we just append the index straight up with the square, and we just pass it into our plot and save the graph. You may have noticed that we didn't use this variable val here. In programming, we normally indicate a read-only variable with an underscore. In Python, you can have a variable named an underscore and actually use it. So we could come in here and we could actually print on each iteration what underscore is, which would be the value of the y. So when we do this, we have we have 100, 200, 300, 400, 500. But just in programming, in many languages, we just indicate that we're not going to be using this variable, and it's just a read-in temporary value as an underscore. So this is a good way to represent it, and this is some nice Pythonic code, easy to read, using the enumerate method.